Albert Einstein. Albert Einstein, architect of the modern cosmos. Albert Einstein, 1879 to 1955, stands as a monumental figure in the history of science, a man whose name has become synonymous with genius. His theories fundamentally reshaped our understanding of the universe, from the largest cosmic scales to the smallest subatomic particles. Yet, beyond the scientist was a complex man, a philosopher, a musician, a humanitarian, and a reluctant icon whose influence extended far beyond the laboratory into the realms of culture, politics, and even psychology. Personal information and early life. Born March 14, 1879 in Ulm, Kingdom of Württemberg, German Empire. Died April 18, 1955, age 76, in Princeton, New Jersey, U.S. Parents: Hermann Einstein, an engineer and salesman, and Pauline Koch, a homemaker. Sibling: Maria Maya Einstein, his only sister, with whom he shared a close bond throughout his life. Einstein's early life was marked by a quiet curiosity. He was a late talker, leading his family to initially worry about his development. He disliked the rigid, rote learning style of the German school system, which he found stifling to his creative and inquisitive nature. A pivotal moment in his childhood was receiving a magnetic compass at age 5. The mystery of the invisible force acting on the needle captivated him and sparked a lifelong fascination with unseen forces in nature. Growth in education. Einstein's intellectual growth was unconventional. While he excelled in mathematics and physics, he often clashed with authority and resisted subjects he found uninteresting. 1. Luitpold Gymnasium, Munich. He found the school's militaristic discipline oppressive. He left at age 15 using a doctor's note to join his family who had moved to Pavia, Italy. 2. Swiss Federal Polytechnic, ETH Zurich. After failing the initial entrance exam on the liberal arts sections, while scoring exceptionally in math and physics, he attended a cantonal school in Aarau, Switzerland. He successfully enrolled at ETH in 1896. It was here he met his first wife, Mileva Merrick. 3. The Patent Office. After graduating in 1900, Einstein struggled to find an academic position. In 1902, with the help of a friend's father, he secured a job as an assistant examiner at the Swiss Patent Office in Bern. This seemingly mundane job was a blessing in disguise. It provided a stable income and, crucially, the mental space to conduct his famous thought experiments, Gedankenexperimenten, while evaluating patent applications for electromagnetic devices. The Miracle Year. Annus Mirabilis, 1905. While working at the Patent Office, the 26-year-old Einstein published 4 groundbreaking papers in the scientific journal Annalender Physik. These papers would revolutionize physics and set the stage for his entire career. 1. On the photoelectric effect. He proposed that light is not a continuous wave but is composed of discrete packets of energy called quanta, later named photons. This was a foundational paper for quantum theory. 2. On Brownian motion. He provided empirical evidence for the existence of atoms by developing a mathematical model for the random, jittery motion of particles suspended in a fluid. 3. On the electrodynamics of moving bodies, special relativity. He reconciled Maxwell's equations for electricity and magnetism with the laws of mechanics by introducing a radical new theory of space and time. 4. Does the inertia of a body depend upon its energy content? This paper introduced his most famous equation, E equals mc squared, demonstrating the equivalence of mass and energy. Core theories and scientific contributions. A special theory of relativity, 1905. This theory is built on 2 simple but revolutionary postulates. 1. The principle of relativity. The laws of physics are the same for all observers in uniform motion, i.e., not accelerating. 2. The principle of the constancy of the speed of light. The speed of light in a vacuum is the same for all observers, regardless of their motion or the motion of the light source. Implications. These postulates led to startling conclusions that shattered the Newtonian concept of absolute space and time. I. Time dilation. A moving clock runs slower than a stationary clock from the perspective of a stationary observer. 2. Length contraction. An object appears shorter in its direction of motion as its speed increases. 3. Relativity of simultaneity. Two events that are simultaneous for one observer may not be for another. B. Mass-energy equivalence, E equals mc squared. This equation is a direct consequence of special relativity. 1. E is energy. 2. M is mass. 3. C is the speed of light. Meaning, mass and energy are different manifestations of the same thing. A small amount of mass can be converted into an immense amount of energy, as C superscript 2 is a huge number. This principle is the basis for nuclear power and atomic weapons. C. General Theory of Relativity, 1915. This was Einstein's masterpiece, a new theory of gravity. He spent a decade developing it. 1. Core idea. Gravity is not a force as Newton proposed, but a consequence of the curvature of a unified four-dimensional fabric called spacetime. Mass and energy tell spacetime how to curve, and the curvature of spacetime tells mass how to move. 2. Analogy. Imagine a bowling ball, a massive object like the sun, placed on a stretched rubber sheet, spacetime, creates a depression. A marble, a smaller object like Earth, rolled nearby will follow the curve created by the bowling ball, appearing to be attracted to it. 3. Confirmation. The theory predicted that light from a distant star would bend as it passed the sun. This was famously confirmed by Sir Arthur Eddington during a solar eclipse in 1919, catapulting Einstein to international fame. D. Other contributions. 1. Quantum theory. While his paper on the photoelectric effect was foundational, Einstein was deeply troubled by the probabilistic nature of quantum mechanics, famously stating, "God does not play dice with the universe." His debates with Niels Bohr on the topic helped sharpen and define the field. 2. Bose-Einstein condensate. In collaboration with Sachendranath Bose, he predicted a new state of matter that occurs at temperatures near absolute zero. Certificates, achievements, and recognition. 1. Nobel Prize in Physics, 1921 awarded, for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. Notably, it was not awarded for relativity, which was still considered too controversial at the time. 2. Copley Medal, 1925, from the Royal Society. 3. Max Planck Medal, 1929, from the German Physical Society. 4. He received dozens of honorary doctorates from universities across the globe. Time magazine named him Person of the Century in 1999. 5. Time magazine named him Person of the Century in 1999. International influence and countries visited. Einstein was a true internationalist. His fame made him a global ambassador for science and peace. 1. Europe. He held academic positions in Bern, Zurich, Prague, and Berlin. He was a professor at the Prussian Academy of Sciences in Berlin from 1914 until 1933. 2. United States. He first visited in 1921 to raise funds for the Hebrew University of Jerusalem. With the rise of the Nazi Party, Einstein, being Jewish, renounced his German citizenship and emigrated to the U.S. in 1933. He took a position at the Institute for Advanced Study in Princeton, New Jersey, where he remained for the rest of his life. 3. The letter to Roosevelt. In 1939, concerned that Nazi Germany might be developing an atomic bomb, Einstein signed a letter to President Franklin D. Roosevelt, urging the U.S. to begin its own nuclear research. This led to the Manhattan Project. Einstein later expressed profound regret over his role, stating, "Had I known that the Germans would not succeed in developing an atomic bomb, I would have done nothing." 4. Global advocate. After the war, he became a passionate advocate for nuclear disarmament, civil rights, and a world government to prevent future conflicts. He traveled and lectured in Japan, South America, and across Europe, using his platform to promote his humanitarian ideals. Family and social life. Einstein's personal life was complex and at times tumultuous. Mileva Merrick, first wife of fellow physics student at ETH. They had a daughter, Liesl, whose fate is unknown. She likely died in infancy or was given up for adoption, and 2 sons, Hans Albert, who became a professor of hydraulic engineering, and Eduard, who suffered from schizophrenia and spent much of his life in institutions. The marriage was strained by Einstein's intense focus on his work and ended in divorce in 1919. There is ongoing historical debate about the extent of Mileva's contributions to his early work. Elsa Lowenthal, second wife, his first cousin, whom he married in 1919. She was more of a gatekeeper and protector than an intellectual partner, managing his household and fame until her death in 1936. Social circle. Einstein was not a recluse. He enjoyed deep conversations with a close circle of friends, including physicists like Niels Bohr and Paul Ehrenfest, and philosophers like Bertrand Russell. Other interests and passions. 1. Music. Music was essential to Einstein. He was an accomplished violinist and often turned to playing Mozart and Bach for relaxation and inspiration. He said, "Life without playing music is inconceivable for me. I get most joy in life out of music." 2. Sailing. He loved sailing on the lakes near his homes in Germany and the US. It was another way for him to be alone with his thoughts. 3. Philosophy and religion. Einstein was not religious in a conventional sense but possessed a deep sense of awe and wonder at the universe's harmony, which he called a cosmic religious feeling. He was heavily influenced by the philosopher Baruch Spinoza, who equated God with nature. Inspirations. 1. Scientific. He stood on the shoulders of giants, most notably Isaac Newton, whose laws of motion and gravity he sought to generalize, and James Clerk Maxwell, whose equations on electromagnetism were a direct inspiration for special relativity. 2. Philosophical. David Hume's skepticism about empirical knowledge influenced Einstein's willingness to question long-held assumptions about space and time. Baruch Spinoza's pantheistic philosophy resonated with Einstein's view of an orderly, comprehensible, but impersonal universe. Famous quotes. Meaning and implication. Imagination is more important than knowledge. For knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution. Meaning. This is not a dismissal of knowledge. Rather, Einstein argued that knowledge is the toolkit, but imagination is the architect. True breakthroughs come from imaginative leaps, thought experiments, that go beyond what is currently known. 2. God does not play dice with the universe. Meaning. This famous quote encapsulates his rejection of the inherent randomness and probability at the heart of quantum mechanics. He believed that there must be an underlying deterministic reality that we had not yet discovered. It was a statement of scientific faith in order and causality, not a theological declaration. 3. The important thing is not to stop questioning. Curiosity has its own reason for existing. Meaning. This is the core of Einstein's scientific and personal philosophy. He believed that relentless curiosity, the simple act of asking why, is the engine of all understanding and progress. Influence on psychology. While not a psychologist, Einstein's ideas had a subtle but significant influence on the field. 1. Relativity and perception. The idea that time and space are relative to the observer resonated with movements in psychology like Gestalt psychology, which emphasizes that our perception of the whole is different from the sum of its parts and is dependent on context. 2. The observer effect. In quantum physics, the act of observing a particle changes its state. This has a powerful parallel in social psychology and anthropology, where the presence of a researcher and observer can alter the behavior of the subjects being studied. 3. A model for thinking. Einstein's method of using thought experiments and seeking simple, elegant principles to explain complex phenomena provided a model for holistic and systems thinking in psychology and other social sciences. Legacy. Einstein's legacy is twofold: scientific and cultural. 1. Scientific legacy. He fundamentally altered our understanding of space, time, gravity, and energy. His theories are essential pillars of modern physics and have practical applications in technologies like GPS, which must account for both special and general relativistic effects, nuclear energy, and lasers. 2. Cultural legacy. Einstein became the archetypal genius. His disheveled hair and gentle eyes made him an instantly recognizable and beloved global figure. He represents the power of human intellect and the importance of curiosity. He proved that a scientist could also be a profound humanitarian, using his platform to fight for justice, peace, and reason. His brain was preserved and studied after his death, a testament to the world's fascination with the source of his genius. Conclusion. Albert Einstein was more than a physicist. He was a force of nature in his own right. His genius lay not just in finding the answers, but in his unparalleled ability to ask the right questions, questions that challenged the very foundations of reality. He looked at the universe with the wonder of a child and the rigor of a master mathematician, ultimately composing a new symphony of the cosmos where space and time danced to the tune of mass and energy. His scientific contributions are a permanent and foundational part of human knowledge, while his life story, that of a patent clerk who reimagined the universe, a pacifist whose work led to the atomic bomb, and a global icon who never lost his humility, continues to inspire and challenge us to look at our world with relentless curiosity and profound imagination. The end. Thank you for watching. Like, comment, and subscribe.